Hello class, welcome to your next video. Today we're going to talk about prime factorization. So prime factorization actually helps us with greatest common factor and helps us with least common multiple, but I decided to do it last because I think it would make a little bit more sense to you instead of doing it first and then it's fresh in your head and you remember it. So prime factorization, here's what it means. It is the factorization of a composite number into a prime number. So I am taking a composite number like 46 and I am breaking it down into its prime numbers, its prime factors. So what we do to find prime factorization is we use what's called a factor tree. So we will use a factor tree to solve. And I'll show you here what that means. We'll do a few examples. Okay, so with this, okay, our first example, let's say I have the number 24. What I'm asking you to do is I want you to take 24 and I want you to write it in its most prime numbers. So I'm doing a tree. So I ask myself, what times what is 24? It can be anything you want. Any numbers, does not matter. Any factor that's whatever times whatever equals 24. The first set of numbers that pops into my head is 4 and 6. So I'm going to make a tree coming out of 24 with 4 and 6 because 4 times 6 is 24. So then I ask myself, is 4 prime? No, it's not. It's still a composite number. So what times what is 4? Well, 2 times 2 is 4. So I break that up and I write 2 times 2. Then I ask myself, what about 6? 6 is also composite, so what times what is 6? 3 times 2 is 6. 2, 2, and 2 are all prime numbers. 3 is a prime number. So that means that I have 2 times 2 times 2 times 3. I have 3 2's. So instead of writing 2 times 2 times 2, I would write 2 to the third power because there are 3 2's, and then I would write times 3. That is my prime factorization of 24. Okay, so let's try another one. If I gave you the example 60, you ask yourself the question, what times what will give you 60? It can be anything that you want. So the first thing that pops to my head when I see 60 is, oh, well I know that a 10 goes into 60. And that's 10 times 6. So 10 times 6 is 60. So 6 and 10 are factors. 6 is composite because I know that 3 times 2 is 6. And I know that 2 times 5 is 10. Then I am left with 3, 2, 2, and 5. They are all prime numbers, so I cannot do anything else. So I'm actually going to want you guys to circle the numbers that are prime. So I should have circled this 2, 2, 3, and 2 over here. So circle your numbers when they are prime, so you know you are done with them. Then write them out. 2 times 2 times 3 times 5. I'm writing them in numerical order, least to greatest. And I have 2 2's. So just like over here, we wrote 2 to the third because there are 3 2's. I'm going to write 2 to the second because there are 2 2's. Then I will write times 3 and times 5. And that is my answer. Okay, then I'm going to go to example 3. And I want you guys to do the number 12. So I asked myself, what times what will give me 12? Well, the first one that pops into my head is 3 times 4 is 12. 3 is a prime number, so I am going to circle it because it is prime. 4 is not prime, so I have to keep going, and that is 2 times 2. So it is okay that one part of your tree stops and the other part keeps going. There is nothing wrong with that at all. And then I have a 2 and a 2. So now I'm going to write them in numerical order, least to greatest order. So I have 2 times 2 times 3. Notice I'm only writing down the numbers that I circled. And then there are 2 2's. So I would write 2 to the second times 3. And that is my answer. So I want you guys to try one of these on your own. This is going to be example 4. The one I want you guys to do is 32. So I want you to write out the prime factorization of 32. So I want you to pause this video, stop this video, do whatever you need to, and solve that question for me before you move on, because the next thing isn't the same that we're doing here. So I want to make sure you are learning that they are separate. So solve that problem, pause this video, and restart when you are done. Okay, so we can use prime factorization. So I'm going to label this prime factorization. With GCF and LCM. So we can use, sorry, that was a little bad. There you go. We can use our prime factorization to find our least common multiple and our greatest common factor. Okay, so the way that we do it is you will obviously get two numbers. Okay, so let's do example 1. I want you to find LCM and GCF of 15 and 6. So I want you guys to find the LCM and the GCF of 15 and 6. So we need to write out 15 and we need to write out 6. And we have to use the tree prime factorization method. So first things first, do prime factorization. Do what you just did. Okay? I'm going to use my tree. What times what gives me 15? Now notice I've never done 1 and 15 because that doesn't make a difference. So it has to be another number because 15 is not prime. So it is 5 times 3. Well, 5 is prime, so circle it. 3 is prime, so circle it. Then I'm going to move over to 6. 6 is a composite number, so what times what will give me 6? 3 times 2 will give me 6. So I'm going to circle 3 and 2 because they are both prime numbers. So step number 1, find the prime factorization. Do your prime factorization of 1 and 2. Okay, if there's a third number, do it with the third number as well, but we're going to stick with just 2 numbers for now, okay? So then I want to find the GCF. The GCF is the first easy one to find, because GCF is the largest number that they have in common. They have to have it the same. Okay, so I'm actually going to draw a Venn diagram. If you don't know what a Venn diagram, it is 2 circles that overlap each other like so. Okay, we're going to have this one be our 15 and this one be our 6. And then we have a number in the middle. So the way that this works is you put wherever the number goes. So if I look at 5, well, 5 only goes into 15, so I'm going to write the 5 in the 15 circle. I see the 2. 2 only goes into 6, so I write the 2 in the 6 circle. I have a 3 in common. So because the 3 is in common, the 3 goes in the middle. So the common numbers, same numbers. Notice I'm only writing that 3 down once. I'm not writing it down twice. I'm only writing it down once, because they are the same, so I only need to write it down that one time. So the greatest common factor is the largest number that they have in common. So I only look at the middle, and they have only a 3 in common. So that means my greatest common factor is that 3, because it is the only number that they have in common. Then to find the least common multiple, we need to multiply just like we did with our cake method, but this time we are going to multiply all of the numbers that are under the 15 by all of the numbers that are under the 6 and by the number they have in common, which means I'm going to take 5 times 3 times 2. And I'm going to make my life easy. 3 times 2 is 6. And 5 times 6 is 30. So my least common multiple is 30. Okay, let's try another example, because I know this is kind of weird. So example 2. This time I'm going to give you 12 and 30. So LCM and GCF of 12 and 30. So step 1, you need to find the prime factorization of 12 and 30. So I write down a 12, and then I ask myself, what times 12? What times what gets me to 12? Well, I know 3 times 4 is 12. 3 is prime. 4 is composite, because 2 times 2 is 4. So I know that 2 and 2 are prime. So that is my prime factorization tree. So I have 3, 2, and 2 will get me to 12. They are all the prime numbers multiplied together to get 12. I'm going to do the same with 30. I ask myself, what times what will get me to 30? Well, the first thing that I can think of is 3 and 10. So 3 times 10, I know that 3 is prime. So I'm going to circle it. 10 is not, but it is 2 times 5, and those are both prime, so I am going to circle them. So first step, you have to know how to find your prime factorization. You don't have to write it like we did on the first page of notes, but you have to know how to find it. So now I'm going to make my circles. I have my circle for 12. I have my circle for 30, and then I have my space that is in between, so I have my numbers that are common, my common numbers. So that's what I want to do first. Let's first find our numbers that are common. So I see a 3 and 12, and I also see a 3 and 30. That means that I'm going to write down a 3 in the middle because I see a 3 that they have in common. Then I see that there is a 2 and a 2. Now notice I'm not using this 2 because 2 and 2. I have to match them up perfectly. I can't say, oh, 2 2s and 1 2. That's not the same. It's 1 and 1. So then I'm going to write a 2 in the same common numbers because they have a 2 in common. Then if I go to the next number, I see another 2. Well, that 2 I do not have in common with the 30, so that 2 has to go under my 12. Then I have a 5, and that 5 is not common with your 12, so it has to stay with the 30. So now I can find my greatest common factor, and your greatest common factor is your common numbers, this 2 and 3, when you multiply them together. And 2 times 3 is 6, so your GCF is 6. Because it is the numbers that are in the common area multiplied together. Then to find your least common multiple, we multiply all of the numbers we see. So I'm going to multiply 2 times 2 times 3 times 5 together. 2 times 2 is 4. 3 times 5 is 15. So I need to do 4 times 15. And once I do 4 times 15, I'm going to figure out that that is 60. So my least common multiple of 12 and 30 is 60. I know that that looks like a lot of work. It is a lot of work. But unfortunately, we do have to know this method, just like you have to know the cake method. So you will have to do this method on homework. You can't just be like, oh, I like cake method better, I want to do cake method. You have to use this method. Okay? So let's do one more together, and then I will have you do one by yourself. So example 3, I have find GCF and LCM of 48 and 42. So I need to find 48 and 42. I need to do my trees. What times what gets me to 48? The first thing I can think of is 6 and 8. So 6 times 8 is 48. And then I have 3 times 2 is 6. And those are both prime numbers, so I'm going to circle them. Then I have 4 times 2 is 8. Well, 4 is not prime, so that would be 2 times 2. And those 2's are prime, so I'm going to circle them. And this last 2 is prime, so I'm going to circle it. So that one was a little bit bigger, a little bit more numbers. That's okay. I'm going to do the exact same thing with 42. 42, I've got what times what gets me to 42? Well, I know 6 times 7 is 42. And then I know that 3 times 2 is 6. And 3 and 2 are both prime. And 7 is also a prime number, so I can circle that as well. So once you draw your trees, you need to draw your circles. This circle is 48. This circle is 42. And I need to first find the numbers that they have in common. So I see a 3 circled and a 3 circled. So I'm going to underline that I've used that 3, and I'm going to write it in my commons place. I have a 2 and a 2, so I'm going to underline my 2's, and I'm going to write it in my common place. However, I do not have a 2, 2, and a 2. There's no more 2's over here, which means I need to write all 3 of these 2's under 48. I have to have all 3 of them there because they are 3 separate 2's. And then I don't have any 7's that match, so that 7 needs to go with that 42. So to find your greatest common factor, it is the numbers that they have in common. So the common numbers are 2 and 3. We need to multiply them together. 2 times 3 is 6, so my greatest common factor is 6. Then I need to find my least common multiple, and I need to take every number that I see. So I have 2 times 2 times 2, that's the 3 2's under the 48, times 2 times 3 times 7, and I need to multiply them all together. Remember, the order in which you multiply does not matter. So I'm going to do 2 times 2 is 4, 2 times 2 is 4, 3 times 7 is 21, and then these numbers are getting pretty large, so I need to make sure that I'm doing my math correctly. So I want to do 21 times 4. That'll actually give me 84. And then I need to do 84 times 4, which is actually going to be 336. So my least common multiple is 336. So very pretty large number for that one. They won't all be that large, I promise. Okay, so I'm going to have you guys do one number for practice, and then we will do a bunch of practice tomorrow for during class time, because I know this can be a really tricky topic, okay? So I want you to find the GCF and LCM of 8 and 20. So find the GCF and LCM of 8 and 20 for homework. Do that on your own, and we will go over it in class tomorrow to make sure you understand it. We will be practicing this topic for a couple of days. You will get homework over it to practice. So I know it seems like a lot of work, but you're answering 2 questions in 1 problem. So good luck. You will do great. We will keep practicing and working on it. Come to class with questions that you have. Have a great rest of your night, guys. Bye-bye.